Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 6, Notes 2. So we're going to be talking about exponential growth. So we're going to be graphing, modeling, and applying exponential growth to exponential functions. So we're going to be doing word problems and graphing and even writing of equations today. So let's take a look at what exponential growth is. Exponential growth takes the form y is equal to c times 1 plus r raised to the t power. Now c is going to represent your starting value, the initial amount. R represents the rate of change. Now when we do math with percents, we never want to put the percent into the actual problem. We always want to convert it to a decimal. So to convert a percent to a decimal, you move it left 2 places. So for example, if we had 15%, the decimal point's here, and we're going to move it left 2 places. So 15% is going to become 0.15. So that's how we use it as a decimal. So you're going to have to do that today. And then t is going to represent the time that has passed. One thing you should always note is that your c value is also your y-intercept. So that's where you're going to be crossing the y-axis. So let's go ahead and let's take a look at this. So first thing we want to do is write out our equation. Well, I'm just going to start by writing it down here. So I'm going to plug in my c, which is 8, and then 1 plus my rate, which is 0.45, and that's going to be raised to the t power. So when you guys give me the actual written out equation, I want you to take the time to actually add those together. So you end up getting y is equal to 8 times 1.45 raised to the t power. So that's the equation that we're going to be graphing. So now it's going to be just like we did on the previous note sheet. I'm going to have 0, 1, 2, 3, and 4. And I'm going to go ahead and I am going to plug in each of those values for t. So I'm going to have 8 times 1.45 raised to the 0 power. Well, when I raise it to the 0 power, that's going to be 1. 1 times 8 is just 8. Then I'm going to plug in 1. 8 times 1.45. Well, that's going to be 11.6. And then again, I'm going to plug in 2. That's 16.82. Be calculating this along with me. Make sure you're doing it right. If not, let me know. We'll take a look at it together. So then here you should get 24.39 and here 35.36. So let's go ahead and let's graph that. So we're crossing the y-axis at 8. So we're going over 0 here and up 8, which is this point right here. For 1, we're going up 11.6, so it's just past 11.5. For 2, we're going 16.82, so that's almost all the way to 17. And then 24 is going to be actually off our graph, so we don't want to quite cross 3. So we're going to keep going up, but we're not going to cross 3 quite yet. So that represents your graph and your equation for number 1. Let's take a look at number 2. So for number 2, what we want to do is we want to maybe convert this fraction to a decimal, because that's what we're used to seeing it. So since r is 1/3, that's going to be the decimal 0.33. So we can go ahead and we can plug that in. So then I get that y is equal to, I'm going to have 6 times, and then in here it's going to be 1 plus 0.33. Well, what is 1 plus 0.33? That's going to be 1.33. And that's going to be raised to the x power or to the t power. So now we're going to go ahead. When we graph it, we usually use x. Okay, so when we graph it, we use x. When we do word problems, we use t because that tells us time. But really, it's telling us the same thing. So again, we're going to set up our graphs. And I'm going to be plugging in each of those exponents. So I have 6 times 1.33, and then that's going to be raised to the 0 power. So this one's going to be 6. And then I'm going to plug in 1. 6 times 1.33 to the first power, that's going to give me 7.98. Again, calculate this with me. Make sure you're doing it right. Then raise it to the second power, that's 10.61. Raise it to the third power, that's 14.12. Raise it to the fourth power, that's 18.77. So now we're ready to graph this. So let's go ahead and do that. So for the first one, we're going over 0, up 6. That's going to be right here. Over 1, up 7.8 or 98, so that's almost 8 on the nose. Then over 2, up 10.61, so that's just past 10, which is right here. Then over 3, up 14, so just past 14 is 14.12, and then 18.77, that's going to be almost all the way up to 19, which is right there. So now I can go ahead and I can connect those dots, and that's going to represent my graph. So that right there is my graph for number 2. All right, let's take a look at number 3. So for number 3, we want to figure out the number of females participating in sports. So it says in 1971 there were 294,000, gosh, that was hard, 105 females in high school sports. Okay, so it's increasing at an average of 8.5% per year. Well, I don't want to leave that as a percent, so I'm going to convert it to a decimal. So that's going to become 0.085 for that decimal. So now let's go ahead and let's write an equation. So my C value is how many females we started with, which is 294,105. And then I want to do 1 plus my rate. So I'm going to do 1 plus 0.085. And as of right now, that's being raised to the t power because I'm just first writing out the equation right now. I don't actually know what t is quite yet. So before I call this equation written, I want to go ahead and add those in the middle. So then I end up getting 294,105 times 1.085, and that's going to be raised to the t power. So that's the exponential equation that represents that situation. So according to this equation, wrote how many females participated in 2005. So I need to figure out how many years passed between 2005 and 1971. So to do that, what I do is I take 2005 minus 1971, and that's going to give me 34. So 34 years had passed. So now instead of writing t, I'm going to write out this original equation, and I am going to raise it to the 34th power. So I have 294,105 times 1.085 raised to the 34th power. Now this is something that you can plug into your calculator exactly as it is written. So you can go ahead and plug that into your calculator. And when you're talking about people, when you're talking about living things, you want to round to the nearest living person. You don't want to leave it as 0.2 of a person. That's not very nice. Remember, if it's 0.5 or greater, you need to round up. 0.4 or below, you keep it the same. So then you get 4,711,004 females. So go ahead, plug that in your calculator. Make sure that's what you get. Make sure you're plugging it in correctly. If it's not, show me what you plugged into your calculator so we can maybe try and figure out what's going wrong in this scenario. Okay? Next, let's go ahead and let's take a look at this next one. Okay, write an equation. So we're talking about Farmington. It has 21,087 people and the growth rate of 1.9%. Again, notice all these words, growth, going up. That's when we know we need to use exponential growth, if it's implying that whatever scenario is happening is going up. So our rate is 0.019. So now let's go ahead and plug that in. So we have y is equal to 21,087 times 1 plus 0.019, and that's going to be raised to the t power because we don't know what t is yet. So now what I want to do is I want to add those two in the parentheses so I can get my final equation. I don't want to leave that addition there. That's addition I can very easily do to make it a nice, neat problem. So I'm going to go ahead and I'm going to write that out. I apologize, my internet's kind of slow. It's not writing very fast. Okay, so then I'm going to have that as my equation. Then it wants us to estimate the population of 2013 and 2017. So first, how many years passed between 2010 and 2013? Well, 3. So that's what I'm going to plug in for t. So I get y is equal to 21,087 times 1.019, and that's going to be raised to the 3 power. So when that's raised to the 3rd power, you're going to plug that into your calculator. Go ahead and do that. Okay? When you do that, you end up getting 22,312 people. Now, that's for 2013. What I want you to do is go ahead and plug in 2017 yourself. See how many you get. So your t is going to be 7, and you're going to need to plug in an exponent of 7. All right, let's take a look at this compound interest stuff, okay? So for compound interest, the formula is that A is equal to P times 1 plus R divided by N raised to the NT. So this is a special form of exponential growth that we're going to use. So we have to remember what each of these variables are. A is your starting amount. A is your amount that you're getting to. P is your starting amount. So A is the answer you want. P is what you're starting with. R is your rate, and notice again it's as a decimal. We never use the percents in the actual problem. N is the number of times that it's going to be compounded per year. That word compounded is going to be really important. Whenever you see the word compounded in a problem, that means you need to use the compound interest formula. And T is going to represent your number of years. So this is kind of a table that will help you figure out your N values. And when you see this word, it means this, and so forth. So when you see daily, that means that your N is going to be 52. When you see weekly or daily, your N is going to be 360 because that's how many days are in a year. Good one, Miss Humbert. All right, so your daily is going to be 360. Your weekly is going to be 52 because there's 52 weeks in a year. Monthly is 12 months in a year. Quarterly, think about a quarter. There's 4 of them in $1, so that's going to be 4. Semi-annually is going to be twice a year, and annually is just once a year. All right, let's go ahead and let's plug in these problems. So let's take a look at the compound interest. Maria's parents invested $14,000. Okay, that's going to be my C value. At a rate of 6% per year, I need to convert that to a decimal, and I get 0.06. Compounded, okay, I need to use my compound interest formula. Monthly, my N is equal to 12. How many will there be in 10 years? Okay, my T is equal to 10. So now I'm going to go and I'm just going to plug this all in to get my answer. So I have A is equal to C, which is 14,000, times, in parentheses, once that gets going here, 1 plus the rate, which is 0.06, divided by the number of times per year, which is 12, raised to the number of times per year times the number of years. Now, for the most part, you can plug this entire thing into your calculator. The only extra step you have to take is multiplying out the exponents. So then you get 14,000 times 1 plus 0.06 divided by 12, and that's going to be raised to the 12 times 10, which is 120. So once you've taken the extra step to multiply out the exponent, you can type everything that I have written there into your calculator. Okay, and remember with money, you want to round to 2 decimal points. So go ahead and plug in your calculator. Make sure you get the answer I do. You get 14,863.49. So watch your rounding. If the third number's 5 or greater, round up. 4 below, keep it the same. So hopefully you got that answer when you plugged in. If not, show me what you plugged in when you see me next, and we'll take a look at it. Let's take a look at number 6. Same deal. So we're starting with 300. That's going to be my C value. The interest rate is 3.5%, so we're going to go ahead and we're going to move that over. So our rate is going to be 0.035. It's going to be compounded semi-annually, so that means my N is 2 for 22 years, so my T is 22. So let's go ahead and let's plug that into the problem. So our amount is going to be equal to our $300. Again, I know I need to use the compounded formula because it says compounded in the original problem. Then it's going to be times 1 plus my rate, which is 0.035, divided by my number of times per year, which is 2, raised to the number of times per year times the number of years. Now remember, I do need to take that extra step to multiply out the exponents. So I'm going to start by doing that. I'm going to multiply out the exponents. So I'm going to keep everything the same because if you round too early when you have decimals like these, it can actually lose accuracy in your problem. So that's why I'm not calculating this part out until I calculate out the whole thing because I don't want to have to round my decimal too early. Earlier it was easier. And then you get that raised to the 44th power. So then this can go ahead and this entire thing can be plugged into your calculator. And when you do that, you end up getting 643.63. So go ahead, plug that in your calculator. Make sure that's the answer you get. If it's not, check with me. So that concludes your note video. Please remember to take that Schoology quiz once you're done watching this. Thank you for listening.